morning, children. Today we will start with a new chapter, that is chapter number 5, Principles of Inheritance and Variation. Like begets like is an important and universal phenomenon of life, as the living beings produce offsprings of their own kind. The young ones always resemble their parents and also with each other, but still we consider that some variations amongst themselves are being observed. The people from different parts of the world appear different, while people of a family have many characters in common. Now, all living organisms reproduce. It is the result in the formation of offsprings of the same kind. The resulting offsprings most often do not totally resemble the parents. This shows that the people from different parts of the world appear different, while people of a family have many characters in common. In this chapter, we will study about the similarities and variations in characters and also their inheritance pattern from one generation to another. Let us start with the first topic, that is Mendel's law of inheritance. Genetics. It is the branch of biology which deals with the inheritance as well as the variation of characters from parents to their offsprings. Now, inheritance is the process by which characters or traits are passed from parents to their progeny or offsprings, that is, from one generation to the next. This is the basis of heredity. And heredity is the transmission of characters from parents to their offsprings. Now, let us study about variation. Variation is the degree by which progeny differs from their parents. And there are two types of variations. The first one is hereditary variation and the second one is environmental variations. Now, hereditary variations are genetical and inheritable. Means the variation occurs in the genes, and as the changes takes place in the genes, they are transmitted from parents to their offsprings. Second type is the environmental variation. These are acquired and non-heritable. They are acquired, means there will be no changes in the genes, but during the lifetime, the changes will be acquired, they will be adopted, they will be taken up by the organisms, and later they are not passed on to the next generation of springs. Humans knew from as early as 8000 to 1000 BC that one of the causes of variation in living things was hidden in sexual reproduction. They exploited the variations that were naturally present in the wild populations of plants and animals to selectively breed and select those organisms that possessed desirable traits. This is done by artificial selection and domestication processes. For example, well-known Indian breed of Sahiwal cows in Punjab. Now, let us study about Mendel's experiment. Gregor Johann Mendel, for first time, approximately in the mid-19th century, conducted experiments to understand the pattern of inheritance and variations in living things. His observations became the foundation of modern genetics and the study of heredity. Therefore, he is also known as father of genetics. He conducted hybridization experiments on garden pea, which is also known as Pisum sativum. This is the biological name of pea. He conducted his experiments for 7 years, that is from 1856 to 1863, and proposed the law of inheritance in living organisms. Gregor Johann Mendel took birth in the year 1822 and died in the year 1884. He was an Austrian monk and he published his results. Translation of the characters in the Natural History of Society of Brunn. He is regarded as the father of genetics. Mendel was born into the family of a poor peasant in Moravia, Austria. He suspended his school education due to poverty in the family. In 1843, he joined a church as a monk. In 1847, he became the head of the monastery at Brunn, Austria, now called Brno in Czechoslovakia. In 1851, he went to University of Vienna to study natural theory and mathematics for 2 years. After his return, he worked as a teacher in natural history and mathematics between 1856 and 1865. During this period, he designed breathing experiments in the pea plant. He carefully analyzed the results, gave a mathematical interpretation. In 1865, he published his results, translation of the characters in the Natural History of Society of Brunn. In 1900, that Mendel's work was rediscovered by 3 scientists independently, that is, Hugo de Vries in Holland, Franz Correns in Germany, and Erich Schermark in Austria. This is St. Thomas Abbey Mendel Museum, and this is Mendel's University. Now let us study about the Mendel's experiment approach. Mendel's methodology during the investigation of the inheritance pattern included mathematical logic and statistical analysis of data. His experiments had a large sampling size that gave greater credibility to the data that he collected. The confirmation of the inferences from his experiments on successive generations of his test plants proved that his results pointed to the general rules of inheritance. Now, Mendel's experimental material. Mendel selected garden pea plant as a sample due to some reasons. The first reason was pea plants are readily available on large scale and has bisexual cleistogamous flowers. Second is pea plants are self-pollinated and can be cross-pollinated. These are annual plants with short life. Okay, these are annual plants with short life. Annual plants means the plants flower once in the year. Okay, and they have short life. So several generations can be studied within a short period of time. Pea plants could be easily raised. They can be easily cultivated. They can be maintained and handled. Pea plants differ in distinct or contrasting traits or characters, which provide many easily detectable contrasting characters. And the hybrids are fertile. So these are the few points because of which the Mendel has selected the garden pea plant for his experiments. Mendel conducted artificial cross-pollination experiments by performing emasculation, that is removal of anther. On several true breeding pea lines. A true breeding line refers to one that have undergone continuous self-pollination and show stable trait inheritance and expression for several generations. Mendel selected 14 true breeding pea plant varieties as pairs, which were similar except for one character with contrasting trait. The contrasting traits are as listed here. If we consider the stem height, which is the character, the contrasting traits were tall and short or dwarf. Then if we consider the second character, seed shape, then the two contrasting traits are round and wrinkled, wherein round is dominant and the wrinkle trait is the recessive trait. Here, tall is the dominant trait and dwarf is the recessive trait. If we consider the third character, that is seed color, yellow is the dominant trait and green is the recessive trait. Whereas if we talk of seed coat color, then green is the dominant trait and white is the recessive trait. Then shape of the pod. Inflated is the dominant trait, whereas constricted is the recessive trait. Pod color, green is the dominant trait and yellow is the recessive trait. Whereas if we talk of the position of the flower, then axial is the dominant trait, whereas terminal is the recessive trait. Axial means you can see here, in between the flowers can be produced, whereas in terminal at the tip or at the end only the flowers are produced. Okay. So these are the 7 pairs of contrasting traits which were selected by Mendel for his experiments. Now, Mendel's experimental procedure. Mendel followed few steps for his experiment, like Mendel observed one trait or character at a time. Example, he crossed tall and dwarf pea plant to study the inheritance of one gene. This plant is the tall plant and this is the dwarf plant or short plant. So he crossed tall and dwarf plant to study inheritance of only one gene. He hybridized plants with alternative forms of a single trait, that is monohybrid cross. The seeds produced by this process were groomed to develop into plants of filial progeny or F1 generation plants. Means when he crossed this two plants which are considered as parents, parental generation. Okay, so the two parents which were selected were, one was tall and the other one was dwarf. These two parents were crossed, and as a result, the F1 generation was obtained. In F1 generation, he found that all the plants were tall. All the plants were tall. And he named them as F1 generation plants or filial 1 generation progeny. He then self-pollinated the tall F1 generation plants to produce plants of filial 2 progeny or F2 generation, F2 plants. Okay, so in the next step what he did is, he has self-pollinated the F1 generation plants. Okay, all the F1 generation plants were tall. So he took the F1 generation plants and he self-pollinated the plants to obtain the filial 2 generation or F2 generation or F2 progeny you can say, or F2 plants. In later experiments, Mendel also crossed pea plants with two contrasting characters known as dihybrid cross. This is known as monohybrid cross. Why monohybrid cross? Because he took only a single trait. Okay, single trait was being taken, that is the stem height. Here in this case, it is stem height. So, when he crossed the parental plants, tall and dwarf, he got that in F1 generation, all the plants were tall. When the F1 generation plants were self-pollinated, he found that out of the 4 plants, 3 plants were tall and only 1 plant was dwarf. So the ratio was 3:1. But when he studied the genotype, genotype means the genetic combination. When it is the tall plant, okay, and it is the true line, the genotype is capital T, capital T. And when it is true breed dwarf plant, the genotype is small t, small t. So the gametes which are produced by this plant will be capital T, and for this plant it will be small t. And when these two plants are cross-pollinated, he found that the genotype of the F1 generation plant is capital T, small t, and phenotype is tall. Now, genotype means this genetic combination and phenotype means the observable feature. Okay, so the phenotype of F1 generation plant was tall and the genotype was capital T, small t. Now, when he self-pollinated this filial 1 generation progeny, that is capital T, small t, self-pollinated. So the gametes which are produced are capital T, small t, here also capital T, small t. And it was self-pollinated, right? So 3 plants which were produced were tall. And the genotype of that 3 plant was capital T for one plant and capital T, small t for another plant. Now capital T is dominant on small t. So when capital T and small t are together, capital T will only express its feature. Okay, so in F2 generation, all the plants, out of the 4 plants, the 3 plants were tall. That is this capital T, and this which have capital T, small t. These 3 plants were tall. And only one plant, the 4th plant which had the phenotype small t was dwarf. So if we consider the phenotypic ratio of F2 generation, that is tall is to dwarf, it is 3:1. Whereas if we observe the genotype of all these four plants. It is capital T, capital T, capital T, small t, and small t. So capital T is for one time, capital T small t is for two times, and small t for one time. So the genotypic ratio is 1 is to 2 is to 1. I hope this much is clear to everyone. So that's all for today. In our next video, we will be continuing the topic Mendel's observation on his experiments, Mendel inferences, and we'll be studying about test cross or back cross. Thank you.